with the revision work for semester 1 chemistry class 10, and today is day 5. And today I have planned to discuss the questions, multiple choice questions from the chapter mole concept and stoichiometry. Okay, so this is the chapter mole concept and stoichiometry. It is the second last chapter for the semester 1 examination. Now, with this, I begin with the questions. So, I am going to write down the questions. But before writing down the questions, let me quickly, just revise the some important formula and some important, notes from this chapter. The first thing, you all should remember, number one, the first thing is it is Avogadro's number, the value, Avogadro's number. Avogadro's number. It is denoted by the symbol capital N and A as the subscript. Okay, that is equal to 6.022 into 10 to the power of 23. This is the Avogadro's number. Then the next, number 2. Number 2 is molar volume. Molar volume. For molar volume, the formula is gram molecular mass divided by mass per liter of gas at STP. So this is the formula for getting the molar volume. Then the next thing, number 3, the third important thing to remember is
Sir,
yes,
for,
yes,
for more concept and stoichiometry, this is cut out of the syllabus. Percentage composition, empirical and
yeah,
molecular formula is only there.
very good, very good, very good, excellent, excellent. Thank you for reminding me.
Yes, sir. I
Okay,
think this is cut off.
yeah, it is cut off. Very good, but there are some numericals. In percentage composition, vapor density, and molecular weight, where you will be required to use these formulas. Are you getting it? And I know the
Yes,
syllabus
sir.
very well. Thank you so much for reminding me. Congratulations. Okay. So the next thing is, if you don't know the English alphabets A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, can you spell diarrhea? Can you write the word diarrhea? It is like
No,
that only.
sir.
It is like that only. So, to be able to do numericals based on vapor density, molecular mass, empirical and molecular formula, whatever I am giving will be required. Are you getting it? So, when I will give you the question, that time I will show you where this formula are used. Okay. So, I'll be very, very happy if you remove the smartness out of your mind and be very humble and be very diligent, a very nice, sincere student, and pay attention to what I am explaining. Am I clear? Am I very clear? Yes? Okay. Otherwise,
Yes,
there
sir.
was no need of me. Otherwise. Okay. The next thing, number 3, the formula required is, it is called relative. It is called relative atomic mass. Relative atomic mass is equal to, the short form for relative atomic mass is RAM. RAM. It is equal to mass of one atom mass of one atom of an element divided by mass of one atom of
carbon 12.
hydrogen. Okay, you can put carbon 12 also, you can put hydrogen also. Okay, then after that, the next important formula which is required for you all to remember is number 4. Number 4, relative molecular mass. Relative molecular mass, that is short form abbreviated as RMM, that is equal to mass of one molecule of a substance divided by mass of one atom of hydrogen. So this is number 4, relative molecular mass. Then after getting all these formula correct in your mind, okay, then we'll jump to what is written in the syllabus. Okay, because without knowing these four things you cannot straight away jump to the next term, which is called vapor density. Vapor density, vapor density, VD. Vapor density, the formula is given as mass of certain volume of gas or vapor divided by mass of same volume or equal volume, same volume of hydrogen. Okay, it seems Mamta Banerjee is moving around here and there. Never mind.
Yes, sir.
Then
Yes,
this
sir, mom.
formula can be shortened. Mass of certain volume of gas or vapor, it is called its respective molecular mass. It's called respective molecular mass. Okay, divided by 2. Okay, so this is an important formula. Okay, so vapor density, you can say the sixth formula is like this. Molecular mass is equal to twice into
Vapor density.
vapor density. Twice into vapor density. Okay. Then number 7, my dear students, very smart, intelligent students. Number 7, molecular formula is equal to empirical formula. Empirical formula, close the bracket, and n over here. This n is a factor. It is a factor which will be used in the calculations. Okay. Now this n, number 8, the last formula over here, this n which you saw just now is equal to molecular formula weight molecular formula weight divided by empirical formula weight. Okay, so these are the 8 important formulas which you must keep in mind and use them no, intelligently in your numericals based on the syllabus. So, my dear students, we move to the questions now. We move to the questions from the chapter, which are called multiple choice questions, MCQs, from this chapter, mole concept and stoichiometry. Okay, the first question, that is number one. Number one. Okay. Are you ready to face the questions? Not ready.
Yes, sir.
Okay.
Yes.
So the questions are here. The empirical formula of a compound is capital C, capital H. It is hydrocarbon. Full stop. The molecular weight, the molecular weight of the compound is 78 gram. Full stop. Its molecular formula will be dash. Options are given. First option number A, it is given C2H2. Option number B is given C3H3. Option number C is given C4H4. Option number D is given C6H6. Okay. Now you can do inky, minky, ponky also, but that will not always take you to the correct answer. You'll have to do a working. You have to work out the answer. Now, here you have to apply the formula. The molecular weight is given 78, and the empirical formula is given, that is CH. And you are students of class 10 already, and in class 10 you already know the atomic masses of carbon is 12 and hydrogen is 1. This is already known to you. Okay. Okay. So now, what is the formula to get the value of n? N, the factor n over here. This is the working I'm doing. How do you get the value of n? Look at the formula which I have just
Molecular
given.
formula weight.
Yes, molecular formula weight
Molecular
divided by, yes.
by
So molecular formula weight
formula weight.
D.
divided by empirical formula weight. So molecular formula weight is given 78. 78. And you calculate the empirical formula weight. How will you calculate? 12 plus 1?
12,
13. So I write over here 13. Isn't it? Because it is CH, no? It is CH over here. It is CH. So 12, one atom of carbon and one atom of hydrogen. So 12 plus 1, 13. So now 78 divided by 13. How much? 13 1 are 13, 13 2 are 26. How much? It is coming 6. Okay, good. Wonderful. We got the factor as n. Now they are telling us to get the molecular formula. So therefore, molecular formula, the formula is, empirical formula is CH. Outside n. The value of n is how much?
6.
6. So I'll write CH outside 6 over here. After putting that 6 outside, I'll put the 6 inside now. It becomes C6 H6. So what is the answer? What is the answer? Answer is D. Option D. Correct.
Option D.
Correct. It is correct. So did you see how we do the working?
Yay.
Did you see? Now,
Yes, sir.
Yes,
for
sir.
your semester one examinations, you will not get so much time to do the working in the rough over there. You will not get. Mark my words and remember my words. You will have to use this formula in your mind. You'll have to apply this formula in your mind and get the value of n. And again, apply this formula in your mind and put the value of n in this second formula and get the molecular formula. And then tick the correct option or write the correct
Yes.
option. Are you getting it? I am not telling a lie. Okay. If I am telling a lie, you tell me.
Okay,
I will
sir.
clarify your doubts. Okay. That was number one.
No, sir.
That was number one. Wonderful. Now, let us see some of the smart fellows, those who are saying that this is not there in the syllabus, this is there in the syllabus. This is the question for them. Okay. Number two. Because if you think you know the syllabus, then I know the syllabus 10 times more than you all. Okay. So number two. 4.8 grams of element A, capital A, atomic weight is equal to 48. The element has atomic weight 48. Was combined was combined with 3.2 gram of element B, capital B, and element B atomic weight is equal to 16. It is 16. Okay. Now to form an important industrial pigment pigment okay, put a full stop. Then the formula of the pigment is put a dash over here, and there are options given. Option A, the first option is titanium trioxide, Ti2O3. Okay, that is the first option. That means A, this element A, it is supposed to be titanium. Atomic weight is 18. The second option, it is Ti2O. Okay. The third option is TiO2. Option D, it is TiO. Okay. Now see, look at your smartness now. Try to use your smartness. And this is a problem based on empirical and molecular formula. Okay. So now work about how will you do this sum now. I'm very happy with this sum. Come on. What will you do?
Nothing.
You do nothing. Yes. Yes, Daxis. Yes, Daxis. Sanda?
Yes, sir.
Are you Sanda now?
Yes, sir.
Yes.
Yes, sir.
That's why. That's why. Now, how will you proceed? Tell me.
Great.
Yeah, okay. Sonso. Become Sonso now. Okay, now see. Now see the element A. Mass of element A. Mass of A in the compound is 4.8 gram. Mass of B, it is 3.2 gram. What is the total mass?
Euro 48.
48. No, mass of A. Mass of A is 4.8 gram. This 4.8 gram. Okay. Are you getting it? If you are like that, you will think others also like that. Okay, Lakshis. If you are like that, no, you'll think others also are like that. So don't think like that. Start loving that. Now mass of A is 4.8 gram. Mass of B. I'm not talking about the atomic weight. I'm talking about the masses given in the actual compound AB. Okay. Now mass of B is 3.2 grams. So what is the total mass?
8 grams.
Yes, 8 plus 2 is 10. It is coming to
8.0.
8.0 gram. Okay, wonderful. Fantastic. Fantastic. So now what you do is get the percentage. Percentage of A. Percentage of A will be 4.8 divided by 8.0 into 100%. Simplify this very happily. And then percentage of B. You will get 3.2 divided by 8.0 into 100%. Simplify this also very happily and tell me the answer. I am waiting for your lovely answers. 4. First get the percentage. Get the percentages. Percentage of A and percentage of B.
A
And we
equals 60%.
A is 60.
60%.
Is it 60?
A
Exactly.
is 60%.
A is 60. So if A is 60%,
Yes, sir.
then B will be how much? 40%. Yes or no? 40%. Okay, wonderful. So
Yes, sir.
this is what we have obtained. We have obtained the percentage of A and the percentage of B in the compound which is formed between A and B. Now, after this, my dear students, who are very wise over there, we are going to draw a table. You know what is a table? Not a table made out of what do you call this? What do you call
Wood.
wood
Wood.
or
Wooden
uh,
table.
plywood and all, you know.
Plastic.
Plastic.
Okay, not something like that. Okay, so we'll make a table, you know. We'll make a table using a pen and paper.
Plastic table.
Okay, not plastic table. So the first column will write element column. The second column will write percentage composition. Okay. The third column will write their respective atomic weights. Okay. The fourth column will write relative uh, relative relative number of atoms. Okay. And last column will write simple ratio. Simple ratio. Simple ratio. Okay. So this is what we're going to remember. Now elements A. Element A, which is titanium, I'll write Ti. Element B, it is oxygen, so I'll write O. Okay. And then percentage of A, we got how much? 60%. No?
60 and
60.
40.
And over here, percentage of B is 40.
16.
Now,
40.
now, my dear boys, atomic weight of A was given how much? 48.
48.
Given 48. Atomic weight was given 48. And atomic weight of B was given 16. Let me check, let me verify.
16.
Otherwise, I might go wrong. Okay. B was given 16. Correct. Now, after that, I'll draw a line. And now, first thing I'll calculate is relative number of atoms of A and B. To get the relative number of atoms of A, I must divide 48. I must divide 60 by 48. 60 by 48. To get the relative number of atoms of B, I divide 40 by 16. Okay, now simplify this. 60 by 48, 12 4s are 48, 12 5s are 60. This is 4 4s are 16, 4 10s are 40, 2 2s are 4, 2 5s are 10. So this is 5 by 2, this is 5 by 4. 5 by 4 is coming how much? 5 by 4 is coming how much? 1 point. Simplify it. Work up to
25.
3 decimal places, okay? How many places? 3 decimal. 5 divided by 4. 5 divided by 4.
1.25.
Wonderful, wonderful. That's marvelous.
1.250.
1.25. Okay, 1.250. Excellent. 3 decimal places. And 5 by 2. 5 by 2. 5
2.5.
divided by 2.
2.5.
It is coming to 2.5. So this is
2.5.
coming 2.50. Okay, wonderful. Excellent. Okay. Now this 1.25 is not 1.5. Okay. Is it 1.5? Is it?
No, sir.
Okay. So this 1.25, what will I do with this? This 2.5, if I
Round
multiply
off.
this, I have to round it off. But if I make this 3, that is not correct. This, how will I make 1.25 a whole number? By multiplying with what number? If I multiply 1.25 by 4,
2.
how much do I get? Will I get a whole number? If I multiply 1.25 by 4, how much do I get? Do I get 5? Do I get 5?
Yes, sir.
Yes.
Yes,
If I
sir.
multiply
Yes,
2.5 by 5, will I get a whole number? No, I will not get. So I cannot multiply it by 4. I cannot multiply it by 4. So what is to be done over here? Yes. This 1.25 in any situation, 1.25 and 2.5, if I multiply them with any common number, a whole number is not going to come. If I multiply this by 5, it will not come a whole number. Just check 2.5. 2.5, if I multiply it by 5, I will get 12.5. If I multiply 1.25 by 5, it will not come a whole number. It will not come a whole number. 1.25, if I multiply it by 5, it will come
It will
6.25.
come whole number 5, no? 1.25.
No, if you multiply up by 5, you are also to multiply by 5 and get a whole number, which is not being
Yes.
possible. Are you getting it?
Yes.
So what we have to do is a small assumption over
Yes.
here. This 1.25 you can take it to be 1. Assume it to be 1. Simple ratio. And this 2.5 you take it to be 2. Are you getting it? Are you getting it? Because
Sir.
these numbers are such numbers that which cannot be multiplied by any number to get a true whole number. That's why we round off 1.25 as 1 and we round off 2.50 as 2. Okay. Now after that, if you look at the formula which is supposed to be, it is coming to TiO2. TiO2, that is titanium dioxide. So this should be the answer. This should be the
Yes.
answer. Now here, see here the board, the council is trying to, you know, the council is trying to make sure whether the student has judicial mental state, whether the student can decide what manipulation is to be done in this step, of the question, and get the correct answer. Are you getting it? So that is how you can score the mark. Because if you put any other values, it will not come to Ti2O3 also. It will not come to Ti2O. That cannot be the answer. It cannot be TiO also because the ratio is not same. So the only possibility is TiO2. So our option for this question becomes which one? Number C. Option number
C.
C. That is TiO2. Okay. So that is one question. It's a very, very good question. TiO2. Now let me tell you the use of TiO2. TiO2, it is used to paint, bonnets of cars, bumper of cars, bumpers. Your four-wheeler, no? Your four-wheeler in front of the vehicle at the bottom, just above the wheels, there is a black colored bonnet bumper. Remember? That is painted with
Yes, sir.
Yes, sir.
titanium dioxide. It is an important industrial pigment. It is resistant. It is resistant to so many things. Acids. It is strong. It is resistant to alkalis. It is resistant to sunlight. It is resistant to rainfall. It is strong. It imparts fiber properties like a fiber to that bumper, which is originally made of, compressed, or you can say thermosetting plastic. Okay. So this is the question based on empirical and molecular formula. Am I clear? Shall we move to the next
Sir.
question, my dear
Yes, sir.
boys? Okay, wonderful.
Yes,
Okay,
sir. You may.
wonderful. Okay. Now the next question is question number 3. No, question number 3. Question number 3. Okay. Now again, for this is the question again for the smart fellows. Those who are very, very smart. Okay. Now here the question goes. Ready? Are you ready to face the question?
Yes, sir.
Okay. Let us. Okay. Now I'm
Yes,
writing
sir.
the question. Molecular mass of benzene, molecular mass of benzene. The molecular formula is C6H6. Is options are option A, 58 AMU, not AMU, not AMU. This is atomic mass unit. AMU stands for atomic mass unit. Okay. Option B. Option B is 68 AMU. Option C is 78 AMU. Option D is 468 AMU. So here you can choose directly because we know carbon atomic weight is 12, hydrogen is
78 AMU.
1. The answer is 78. 12 6 is 72 plus 6 is
78.
78. Correct answer. Wonderful. Okay, very good. Congratulations. Okay, that's correct answer. I like that. I like that. Okay. Now, another question. This is number 3. Number 4. Number 4. The molecular formula. The molecular formula of an organic acid is molecular formula of an organic acid is H2C2O2. Okay, its
Yes, sir.
its empirical formula is its empirical formula is now option A. Option A H2CO. Option B HCO2. Option C HCO. Okay. Option D H2C4O. Okay. So these are the options. 4 options. So what is the empirical formula of this acid?
HCU.
HCO. Correct answer. That's
HCO.
correct. Why it is
Factor
HCO?
2.
Why is HCO? Why? Why? How do you convert the molecular formula to the empirical
Because
formula? There is 2 here, there is 2 here, there is 2 here. These two can cancel each other.
Because it's
2
Always
1 2
divide.
2 1 2 2
so
1
we
2.
take out common.
Yes, we take out common and cancel them. So after dividing by 2, all these 2's, it comes 1 1 1. So HCO is the answer. This acid is nothing but it is you can say HCO CHO. CHO. The empirical formula is CHO. Okay, you can write CHO also. Okay. So this is done. Shall we go to the next question now? Okay, now
Yes, sir.
moving to the next question, number 5. Ah, the the percentage, the percentage of oxygen in magnesium nitrate crystals. Magnesium nitrate crystals. Don't worry, I'll give you the formula of magnesium nitrate crystals. The formula will be given in the examination also. MgNO3 twice dot 6H2O. I'll give you the atomic masses also. Magnesium is 24, nitrogen is 14, oxygen is 16, hydrogen is 1. Okay. So the options given are option A. Option A 72%. Option B 73%. Option C 75%. Option D 74%. Okay, so for this you have to do the working. No, this is also a multiple choice question. You have to do the working. Without working, you cannot do inky minky ponky over here because I am 99.9% sure that you will. If you do inky minky ponky, then you will make it mistake. So do the working quickly. Magnesium is 24 plus nitrogen 14 to the 28 plus 16, oxygen is 16 6 are 96 plus water is 18. 18 into 6, 18 into 6 is the 48. It was 6 plus 108. Correct. 6 8 the 48, 108. So it's 108 over here. If we add all this, you'll get the gram molecular mass. you get the relative molecular mass of magnesium nitrate crystals. So just add this 108 plus 96, 108 plus 96 plus 28 plus 24, 6 plus 8, 14, 14 plus 4, 18, 19, 26, 26, 11, 12, 14, 15, 256. So 256. Just check the answer. That is the gram molecular mass of magnesium nitrate crystals. Okay. Okay. Is it correct?
Correct.
Correct, no? Just check. I might be wrong somewhere.
Yes, sir.
24
Correct.
plus 40 is
It's
28.
correct.
16, 6 is 96. And this one
No,
is
sir, you are right.
18,
Someone is on the door.
18, 6, 6 8 is 48, 108. Okay. Now 256. Okay. Now after that, what is the mass of oxygen you see in this compound? Over here, 3 to the 6. 6 atoms here and 6 atoms here. 12 atoms, no? So 12 atoms of oxygen are there. 6 3 to the 6 over here and 6 over here. So 12 atoms. So 18 into 12. 18 into 12. Okay. So 18 into 12, if you multiply, you should get the answer. How much is 18 into 12? Do in the rough. Do in the rough. 18 into 12.
16.
216.
216.
16.
Huh? 18 into 12. 18 into 12, man.
16.
Yes, sir.
18
216.
216. So that is the mass
216.
of what do you call? Mass of oxygen. No? So therefore, percentage of oxygen will be
Oxygen
equal
is
to
16, no?
yeah. So 16, no. Oh, sorry.
Oh,
Oxygen 16, no? Yeah, correct.
16 into 12.
16, yeah, correct. I made a mistake.
192.
So 16 into 12, no? It's 192. Sorry. It is 192. 192. So your percentage of oxygen become 192 mass of oxygen divided by total mass, that is 256. 256 into 100%. Simplify this. Whatever you get, you choose the answer.
75%.
Are you sure?
Option C.
Oh
Yes, sir.
my God.
Sure.
Wow. Fantastic, man. 100 divided by 256
Genius.
is equal to into 100%. Wow, wonderful. Answer is 75%. So option C. Okay. So that is done. So this is one very important question. Okay. Don't get surprised if this question comes up. Okay. So with this question, we come to the end of this today's question answers from this chapter, mole constant stoichiometry. I will take one more class from this chapter. Okay, because this many questions are not sufficient. Okay, there are some more questions to be done from this chapter. But I'll since you have a break just now, you have to go for a short break. Okay, that's why I would like to end my class here only. And then, but before that, make sure that you all remain in the class because I need to record your attendance. Okay, so just hang on over there. Okay, I am downloading the attendance list.
Have a nice day.
Okay, thank you so much. Have a nice day.
Hello.
Thank you so much. Yes.
Have a nice
Hello, sir.
Diwali break.
So
Uh,
how to convert empirical formula to molecular formula?
how to convert empirical formula to molecular formula? So, if the factor n is known, to convert empirical formula into molecular formula, you must know the factor. Okay. Once you know the factor n, then you divide the multiply the empirical formula with n and get the molecular formula. Suppose just now we did one sum. The molecular formula is given. It was
Yes, sir.
converted into empirical formula by cancelling by a common factor. The numbers which are there,
Sure.
which are the stoichiometric coefficient. Okay. So with this, I'd like to end my class over here. Thank you so much. Have a nice day.
Thank you, sir.
Sir.
Thank